In this video, we're going to be simplifying exponents. So my first example here has two different fractions, and we are to multiply them. When we multiply the two fractions, the numbers that are not exponents, we just treat like how we normally would treat numbers in a fraction, right? So this is a fraction 6 over 5, fraction 21 over 6. When I go to multiply these, I like to work at one row at a time. So going across the top row, I would multiply the numbers, the 6 times the 21. So I'm just going to ignore this multiplication symbol and just continue that fraction bar. So going across 6 times 21 would be 126. And on the bottom, I have 5 times 6, that would be 30. So that's just for the numbers. I treat them like the numbers. For the exponents, I look for the same bases. Bases meaning A. A is the same base here and here. So with the same bases, I add the exponents. -4 plus 5 is 1. So a to the first power, or just a, would be the same thing. So if you do not have an exponent, it's to the first power. I like to put things in alphabetical order. So b would be next, and there's not another b on the top row, so I'm going to keep it as b squared. And for c, I would add the 3 and the 2 to get 5. On the bottom, we have a, b, and c. We don't have any like bases to combine. So I'm just going to put those in alphabetical order. So I have a to the third, b to the -4, and c squared. Okay, next, when we have fractions with our exponents, we subtract the exponents. But again, 126 over 30, these are not exponents, so I'm going to treat them like a regular fraction. To use your calculator to reduce the fraction, so we have 126 over 30. I just type it in, 126 divided by 30, hit enter. So that gives me a decimal. I do not want a decimal, I want to reduce my fraction. So I hit the math button, and fractions, the first thing that comes up, I'll hit enter, and then enter again, and here is my reduced fraction of 21 over 5. So I'll go equals 21 over 5. Now I'm going to do my subtraction rule with the exponents. So for the subtraction rule, you do the top minus the bottom. So a does not have an exponent, it has a little invisible exponent of 1. So 1 minus 3 is -2. When you subtract the exponents, they go in the top always. So I subtract, I get -2, so it's a to the -2. I just write it in the top. For the b value, 2 minus -4, right? So 2, it looks like this. 2 minus -4 would give us a +6. So I have b to the 6. And then c, 5 minus 2 is 3. So I subtracted my exponents, and I put everything in the top row after subtraction. And the last step is the negative exponent. So a has a negative exponent. That will go to my denominator. So just this a will go to the bottom. That will leave me with 21, b to the 6, c to the 3rd, over 5a, and when that negative exponent comes to the bottom, it becomes positive. And that would be my answer. For the next example, we just have a little something different. We have parentheses. So with the parentheses, that means this -3 has to go to the y and the 3. So how this is going to look is 3 to the -3. Notice how I'm not doing 3 times -3, and I'm not raising it to the 3rd power, making my answer negative. I'm just rewriting as 3 with an exponent of -3, and then y. You multiply the exponents when you have parentheses. So -3 times 2 is -6. And the bottom stays the same because we do not have parentheses around the bottom. Okay, What I'm going to do next is my negative exponent rule. So like I said, you can use your different properties at different times. It's all up to preference. But for this one, I want to use my negative exponent rule next. So the x to the negative 1 and y to the negative 2 will go to the top and become positive. So it's x to the positive 1, y to the positive 2. And 3 has a negative exponent, so I'll have 2. This 2 is staying on the bottom. This 3 is going to come down and become positive, 3 to the positive 3. And then y to the positive 6. I'm going to evaluate 3 to the third is 27. So I have x to the first, y squared. 27 times 2 is 54. Just so we know, 3 to the third is 27. All I did was this 27 times 2 to get the 54, and then y to the 6. Okay, I'm not quite done because I have two y's here, so I still need to do the subtraction rule. So this will be 2 minus 6 for y. So I'm just going to come down here. 2 minus 6 is negative 4, and we always put the answer in the top after we subtract over 54. And then y has a negative exponent, so I'm going to do the negative exponent rule again. X over 54, y to the fourth becomes a positive exponent, and that would be my final answer.